So now what we're going to do is we're going to step through, bear with me, this whole second order Taylor expansion about uv of 0, 0. By the way, you guys should appreciate that I am not writing this, so you actually could read it, and there'll be PDFs presented of some sort so that you can get it from there, or you can go to Rick Zalisky's book, it's all there, but believe me, you don't want me to write this, you just want me to be humorous and lighthearted. All right, so here we have our Taylor expansion written just as before. So we're going to knock these derivatives down one at a time. We're going to start with our first derivative, right? We have to do the first derivatives and the second derivatives. So the first derivative we're going to look at, the first derivative we're going to look at is with respect to the u direction. Now u is the offset in the x direction. Okay, just remember that u is the offset in the x direction. And we're going to take the derivative of this function, e of uv, with respect to u. Okay, let's see, well, we've got the square term here, so that gives us this we raise it to single power instead, and then we have to take the derivative of the inside term with respect to u, and let's see, there's no u's in there, that's go away. So there's a u in here, so I have to take the derivative of I of x plus u, y plus v with respect to u. Okay? Not me, you. Okay, anyway. Well, remember, u is in the same direction as x. So the derivative of the image in the u direction is the same as the derivative of the image in the x direction. So I need the image gradient, I sub x. Got it? Good. I'm not going to do v. V is exactly the same thing, except instead of x's, you get y's. Now what we do is we're going to do the second derivative. So we're just going to take the derivative of this with respect to u. Well, there's two parts here, right? We've got this part, and we've got that part, right? So the derivative of a product is u times dv plus v times du, remember? Yes, 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 yes. Except u's and v's is a terrible choice because we have different u's and v's. But basically the derivative of the first times the second plus the derivative of the second times the first, what is that going to look like? That's going to look like this, okay? So we take the derivative of the part that's the image and multiply it, so that just gives us this twice. And then the second one is we take the derivative of the derivative and multiply that by the original. That gives us this second derivative. Okay? The math's pretty easy, you can work it out. This is the e with respect to u term, all right? So we've done the first derivative, the second derivative, u and v are the same. So the only thing left to do from that matrix, we had euu, evv, we need the cross derivative. And that just looks like this, where we take the derivative of the previous one, of u with respect to v now, and we get something that looks like this. And you'll notice that this has the gradient in y, the gradient in x. Remember, x is the same direction as u, y is the same direction as v. And it also has this cross derivative. We haven't talked a whole lot about the cross derivative, and in fact, we're not going to talk even more today about the cross derivative, because later we're going to make it go poof, go away, so we won't even think about it. So now we have our first derivative, u, v is the same. Our second derivative, uu, vv is the same, and our cross derivative, right? Right.